Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So water to orange is 3-2. Ooh. We've got water here and we've got orange squash here. And we're told that we've got 80 centilitres of orange. So we've got 80 here. And we're asked to find the amount of water required. So what we do is we figure out how to get from 2 to 80. Well, we go times by 40. If I times that side of the ratio by 40, I've got to times the left-hand side by 40 as well. 3 times 40 is 120. So I'm going to need 120 centilitres of water. To work out the area of this shape, what I'm going to do is I'm going to work out the area of the big rectangle that is, it's almost a big rectangle. And I'm going to take away the area of this small little bit at the bottom. And I'm going to label this big rectangle A and this little rectangle here B. So to work out the area of A, we're going to do 9.8, which is the width, times the length, which is 5.6. And that will give us 54.88. Now to work out B, we actually have a bit missing. We need to work out what the length of this bit here is. So in fact, let's just choose a different colour just so it shows up a bit more, this length here. So we're going to work out the length of this, and we'll call this C just to make things easier. So to work out the length of C, we're going to do the total length across of this whole shape, which is 9.8, and take away the bits that we know, which is the 4.3 and the 1.2. So we're going to do 4.3 plus 1.2, take that away from 9.8, and when I do that I get the answer of 4.3, and that's a coincidence that it's the same as the left hand one. So we know that that's 4.3, so we actually now we can work out the area of rectangle B, and all we're going to do for that is the 4.3 we've just found times the 2.4, because it's obviously a length of 2.4. When I do that, I get 10.32. Now to work out the area of the whole shape, so the area of the rectangle, all we need to do is the area of A, take away the area of B. So the area of A was 54.88. We're going to take away the 10.32, and that gives us a 44.56. And all the units are in centimetres, so our units for the area will be centimetres squared. So what we did was we found out the total area, which is the whole area of this shape here, and we took away the bit we didn't want, which is the area of this rectangle here. When I do that, I get the area of the bit I do want, which is all of this rectangle, but without that B at the bottom. And this is a really important way of working this out, that you work out the whole thing and take away the bits that you don't want. So there's a formula for percentage increase or percentage change. And it is the change over the original amount times 100%. So to find out the change here, we're going to do the difference between 1,421 and 1,100. So we're going to do 1,421 take away 1,100, which is 321. Divide that by the original amount. So the original amount was the 1,100, and then times by 100%. And that's going to be 29.18%. So to draw a line of best fit, you want to make sure that roughly there's the same amount of data on top of your line and below your line. But if you think about it, this line here would work according to that rule. Clearly, the line of best fit needs to go with the data. So I'm going to start it roughly here, and then just draw a line going down like that. Now, you might notice that sometimes, like say if I draw that, you might notice that we've got 1, 2, 2 below, maybe this one as well, 3 below, and then 1 on top. Don't worry too much if there's not a complete equal amount on top or below. What we mean is if it looks like that, that's clearly wrong, because you've got all of the data below and obviously this one here. You want it roughly so that there's equal amounts at the top and bottom. But if you have it slightly off, so slightly down here or something, don't rub it out. Chances are you'll get the mark. They're quite lenient when you draw lines of best fit. With these questions, we've just got to go around and fill in what we can, and there's going to be some numbers like this one here we can't fill in yet, so we're going to have to be strategic in the order we do it. I'm going to first of all look here and notice that the total of girls and boys is 29, the total of the boys is 18, so take away the 18 from 29 and we get 11. Next one I'm going to fill out is this one. Notice that the total for the green is 15, total for the boys who's picked green is 12, and therefore for the girls it's going to be 3. Then looking around, what's the next thing that we can fill out? We can fill out this one, because the total for the boys is 18, green is 12, blue is 1, therefore we've got 5 left over. Then we can fill out this one, 2 plus 5 is 7. Then we can fill out this one, so 2 plus 3 is 5, then plus another 6 would be 11, and then 6 plus 1 is 7. To answer this question, we basically need to find the lowest common multiple of the 10 minutes here and the 15 minutes here. So we're going to start off just by doing the 10 and 15 times table, so it'd be 10, 20, 30, and 15 times table with 15 and 30. So the lowest common multiple is 30. So after half an hour, these buses will sync up. They'll both leave at the same time. And all buses start service at 9 o'clock. So it will be half an hour after 9 o'clock, which will be 9:30. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chelton, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way. So we'll do D there. Distance from Chelton to Devley is 34 miles. Distance from Devley to Bovlow is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chelton at 9 o'clock. He drives from Chelton to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed distance time triangle. So speed equals distance over time, and we're covering up the time because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it would be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that'd be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. So our sequence, our nth term, is 20 times n plus 6. For the fifth term, n would be 5. So it's 20 times 5 plus 6. 20 times 5 is 100. 100 plus 6 is 106. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage, and that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So first thing to realize is that the formula for a volume of a cylinder is pi r squared h. So what we need to do first of all is work out the volume of the water butt that James currently has. So we're going to do the volume equals pi times the radius, which is 89 squared, times the height, which is 189. And when we do that, we get 1497,069 lots of pi. And I'll keep this in terms of pi just for simplicity. Now, what we want is we want the volume to stay the same. So we're going to keep that as the volume, 1497,069 pi. But we want the radius to change. So instead of the radius being 89, we want the radius to be 103. So times 103 squared. And we're trying to work out what the height is. Okay, so first thing we can do actually is just cross off the pi's from both sides. We don't really need them at all. And then we can get our solving things in, our solving lines, and we can divide both sides by the 103 squared. And on the left hand side we get 141.113 blah blah blah, and on the right hand side we get h. So the height will be 141.113. It says it wants it to 2 decimal places, so that would be 141.11. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in twos, so this will be 28, so the x-coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. The most important first thing that we do is whenever you square something, you times it by itself. So we're going to rewrite this as x minus 15 times x minus 15. And then the way we approach this is exactly the same as we've done with the other ones. We're going to do a multiplication grid. And we're going to do x minus 15 at the top, x minus 15 at the bottom. Then we're going to do x times x, which is x squared, x times minus 15, which is minus 15x. Same again here. And then we've got a minus times a minus, which is a positive 225. Put all the terms together. Now you can see here that we've got the x terms here that will add together. So that would become minus 30x plus 225, and that's actually our answer. So it's x squared minus 30x plus 225. So let's write these numbers out. And the first thing to do is work out what the numbers are going up by. So they're going up by minus 3, because they're minusing 3 each time. So we know that the number before the n is going to be minus 3. So whatever they go up in is the number before the n. Then what we do is we go backwards to find the 0th term. So actually going backwards, we would add 3, and we would find it to be 20. So whatever numbers our 0th term, because 17 is our first term, is going to be what we add to the minus 3n. So it's going to be add 20. So our answer is minus 3n plus 20. There is quite an easy way of doing this question, but I'm going to show you the long way, and then we're going to work out what the quicker way is. So I'm going to pair up the a and the 1, which it suggests in the question. Then I'm going to work out the a and the 2 as a different combination, a3, a4, etc. Then I'm going to look at the b and do the same thing, b1, b2, b3, etc. Then I'm going to work out the c, so all the combinations with c. So how many combinations are there with a? Well, there's going to be 7, because there's 7 numbers. How many with b? Well, there's also going to be 7. And how many with c? Well, there's also going to be 7. So in total, there's going to be 7 plus 7 plus 7, which is 21. And the way I can work that out easily is work out how many combinations there are with spinner 1. Well, there's 3. How many combinations there are with spinner 2? 7. And we just times the 2 together. 3 times 7 is 21. To find average speed, we do the total distance and we divide it by the total time. Now in this question we've got a bit of an issue because the question wants kilometers per hour, but the units are given to us in meters and minutes. So we just need to do some basic conversions. So 1080 meters is going to be 1.08 kilometers, because there are 1,000 meters in a kilometer, so all we need to do is just divide the meters by 1,000. Minutes are a little bit trickier. To get from minutes to hours, all we need to do is divide by 60. And so when you divide that by 60, you get 0.2 hours. So we're going to put the kilometers at the top, 1.08, and we're going to divide that by the hours, which is 0.2. When you do that, you get 5.4. So our answer to 2 decimal places will be 5.40. Whenever you have a one-digit number or a 1 decimal place number, but you're asked to round it to 2 decimal places, you should really put a 0 on the end, which is what we've done. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10. 990. Now when we're looking at limits, with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. So asked to find the bearing of Freetown from Gamley, so that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got a 90 degrees here, we've got a hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out. And we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So A plus B minus C will be, just looking at the top, 9 plus 18 minus 9, 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9. And so that will be minus 18. So our column vector will become 18 minus 18. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9 over 15. And therefore the property of female is 1 minus 9 over 15, which would be 6 over 15. Male on the second bus is 7 over 15. And so female would be 8 over 15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6 over 15 and 8 over 15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome would be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6 over 15 times 8 over 15. So 6 times 8 is 48. And times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4. And that will give you 16. Is it 4? No. You can times top and bottom by 3. And that would be 16 over 75. So either 48 over 225 or 16 over 75. A box plot starts with the lowest value. Then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11, so we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here. So that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. I'm going to start by labeling this triangle. And so I'm going to pick a lowercase a here, uppercase A I mean, for the angle, and then we go opposite it to mark the length with a lowercase a. I'm going to do a capital B here, and then go opposite it to do a lowercase b, and then obviously a capital C here, and then a lowercase c here. Now notice the C's aren't involved in this question at all. It's just the capital A and the lowercase a, and the capital B and the lowercase b. Now when you've got two pairs of angles and sides, you're going to be using the sine rule. Now, the sine rule is either sine A over A, or it's A over sine A. Now, when we're looking for a length, we put the length on the top. So it's going to be lowercase a over sine capital A equals lowercase b over sine capital B. Okay, so we're going to fill in the values. So A is x, capital A is 38, lowercase b is 4, and uppercase B is 67. Now you'll only ever sine an angle, so if you ever put a 4 in there or something, that's not going to be right straight away. Okay, let's work out what 4 over sine 67 is, and that's 4.345, blah blah blah. So we're going to solve this. It's going to be a nice easy solve today, because all we need to do is times both sides by sine 38. And so that will give us 2.675, blah blah blah. And when we round that, we get 2.68. An exponential growth would show an increase from left to right, but the graph we've got in front of us, or the sketch, is showing it decreasing, so it's going to be a decay. The first thing to notice is we actually have two radii here. So we've got this radius here and this radius here, and all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well, and we've got to write that down. So we're going to say angle OBA is equal to 19x, and the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here, and all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees. And this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x equals 180, and let's get our solving lines in. And we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now, we're looking for this angle here. That's angle ABC. Now, there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc., etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees, because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore, angle ABC, which is what we're asked for, is just 90 take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. Okay, so first thing I'm going to do is just a quick sketch of this diagram. And so we're told the lengths are 8 and 6, and the angle between the lengths is 64 degrees. And we've kind of got a missing length down here which we need to find. So we need to find that one. Okay, so let's label them. Now we're going to be using the cosine formula. So cosine formula involves angle A. So we're going to label the angle A. And the one opposite, the one we label as A, is going to be little a. And then little b and little c, it doesn't matter. Right? It doesn't matter which way around you do them. So we're going to write down the cosine formula. So it's a squared equals b squared plus c squared minus 2bc cos a. And so that would be x squared equals, and that will be 8 squared plus 6 squared minus 2 times 8 times 6 times cos 64. And that will be x squared equals 57.916 blah blah blah. And we just need to solve this, and we can solve it by just square rooting both sides. So it would be x equals 7.61000 blah blah blah. Okay, we're asked for the perimeter, and so we need to do 8 plus 6 plus that 7.610 blah blah blah. I've still got on my calculator, and that equals 21.610 blah blah blah. It says it wants its 2 decimal places, so it will be 21.61. So we first of all need to work out the frequencies in each of the bars, and we know that the frequency density is proportional to the frequency over the class width. So we're just going to go through each of these bars and work out what the frequency is. So all we need to do is times the frequency density by the class width. So 4.8 times 10 is 48. The second one is 0.4 times 10, which would be 4. And then the last one will be 0.8 times 5, which will also be 4. Work out the total frequencies. So it would be 48 plus 4 plus 4, which will be 56. So 56 in total, lines in total, and they only want to see the largest 20%. So we're just going to work out 20% of 56, which we can do, we can just multiply it by 0.2, and that'll give us 11.2. Now you can't have 0.2 of a line, so we can just round that to 11. So we're given the equation of the line, which is y equals ka to the power of x, and we're given two coordinates. So we're looking at this first coordinate and put that into the equation. So y is 10 equals ka to the power of x, which is 1. And we're going to do the same with the other coordinate. So we've got 40 equals ka to the power of x, which is 3. Now look at what's happening to both sides. Here we're multiplying by a squared. So a to the power of 1 times a squared is a to the power of 3. And on this side we're multiplying by 4. So we have to be able to conclude that a squared equals 4. And if we square root both sides there, a must equal 2. So if a equals 2, we can just put that into the first equation here. So we've got 10 equals k times 2. And divide both sides by 2, and we get 5 equals k, or k equals 5. So our answers will be k equals 5 and a equals 2. Now check that works. So let's have a look at this second coordinate, and we're going to do y equals, and we're going to do 5 times 2 to the power of 3. 2 to the power of 3 is 8. 5 times 8 is 40. So we know that our equation works. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got 2 radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got 3 of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead. And we've got 3 of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. So if we have x equals the 0.098, 9898, blah, 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 we actually want the repeating pattern to be next to the decimal point. So we're actually more interested in 10x, and so that'd be 0.9898, blah, 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 blah. And we want the repeating pattern to also be in front of the decimal point, so just the digits that repeat. So if we did 100x, it would just be the 9, so we need to do 1000x. And that will give us 98.9898, blah, 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 blah. And we can see here, if we subtract these now, so we subtract the left and the right hand side. On the left hand side, 1000x take away 10x would be 990x. And on the right hand side, we're actually just going to get rid of the repeating pattern. So that would just equal 98. And then we want to solve. So we're going to divide both sides by 990. And divide just means over, so we can just write it as a fraction. Now they are both even, so chances are, well, they will definitely divide by 2. And so we divide top and bottom by 2 and we get 49 over 495. So simultaneous equations we normally solve by working downwards and doing the circles and using the normal method on them, which is solving simultaneous equations by elimination. Sometimes though, when we've got a linear and a quadratic, which we have here, it's not possible to do that method. So what we've got to do is substitute one equation into the other. Now here, it's actually been nice to us in this question because they're both equal to y. So I can replace that second y with the 2x plus 11. I can just put that into that equation there, which is what we're going to do. So we've got 2x plus 11 equals x squared minus 5x plus 4. And we're just going to get everything equal to 0 so that we can solve it as a quadratic. So I'm just going to start by subtracting 11 both sides. So we've got 2x equals x squared minus 5x. What's that going to be? That's going to be minus 7. And then take away the 2x both sides. So we're going to have 0 equals x squared minus 7x minus 7. Now, we know this is not going to factorise nicely because it asks it for 2 decimal places. It's on the calculator paper. Chances are it's going to be quadratic formula we'll need, which we do. So we've got a equal to the coefficient of the x squared, which is just 1. B equal to the coefficient of the x, which is just minus 7. And then c equal to the number unknown at the end, which is minus 7 also. So we write out the quadratic formula. So x equals minus b, and always put them into brackets. So minus 7 plus minus the square root of b squared. So in brackets minus 7 squared minus 4 times a, which is 1, times c, which is minus 7. Oh, and all of that over 2a, so 2 times 1. And when you do that with a plus in that bit there on the calculator, we get the answer of 7.887 blah blah blah. When you do it with a minus, you get the answer of minus 0.887. And don't rewrite the whole formula when you change from plus to minus. Just use the calculator function to go back to this sign and just delete it and change it to a minus. But when we solve, we've got to find out the x and the y values. So we look at this first equation here, which says y equals 2x plus 11. It means to find out what y is, all we need to do is times it by 2 and then add 11. So I'm just going to do that with the first solution we have, so 7.887, blah, blah, blah. I'm going to times it by 2 on my calculator, and then plus 11. And that gives me the answer of 26.774, blah, blah, blah. Then I'm going to do that with the second solution we found, so minus 0.887, blah, blah, blah. Go times it by 2, then add 11. And that gives me 9.225, blah, blah, blah. So to 2 decimal places, our answers are going to be 7.89 and 26.77, or minus 0.89 and 7.23. Here we've got a cubic graph, and we're asked to find out what the equation would be if it was in this form here. So first of all, notice that we've got a negative cubic. A positive cubic looks like this. So we've got a negative cubic, and there is a minus sign there that just deals with that. So we don't need to worry about the fact it's a negative cubic, because that minus sign just means it's negative, fine. Next thing we want to do is find the roots. So the roots are where the line crosses or touches the x-axis. So here we can see it touches it at 6, so when x equals 6. And here, now this is an interesting one, it actually touches it twice. It touches it at -7 the first time going down, and then it touches it at -7 going up. So there's technically 2 roots there. Sort of one root, but it counts twice because it's going down on one root and then up on the other root. So with these, what we need to do is we need to make sure that at x equals 6 and x equals -7, that this equation, the whole thing equals 0. So if we imagine a, what does a have to be to make this whole thing equal 0 when we look at this, the fact that a root is at 6? Well, if we put a at -6, we get x minus 6 in that bracket there. And if we put in the value of 6, then it's 6 minus 6, which is 0, and so the whole thing is 0, because anything times 0 is 0. So if a is -6, let's have a look at b. So what does b have to be? Well, if that's -7, if we put b as +7, then when we substitute in this -7 here into the x, we get -7 plus 7, which is 0. So if b is -7, then the whole, +7, then the whole thing will be 0 at x equals -7. And for the c, we're looking at that last root. Again, it'll be the same, won't it? It'll be x plus 7. Now, you might ask the question, how do you know which is a, which is b, which is c? Actually, it doesn't matter. We could put a at -6 and a at 7 and b at -6 and c at 7. As long as one of these is -6, 1 and 2 of these are 7, you'll always get the right answer. We're going to first of all work out what the function f g of x is. And to do that, what we're going to do is just feed in the value of gx, the function, the kx plus 2. We're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2 and then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3. And it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k, 4 times 2 is 8, plus 3 equals 187, and let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176. And then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. So we're asked to first of all complete the square. So that's what we're going to do. And to complete the square, we've got to remove the minus from the x squared because we've got to have x squared. So we're just going to factorise out the -1 effectively. And we have minus x squared, and this has to be minus 10x. And then we're just going to leave the plus 7 on its own at the end there. And the reason this is a minus 10x is a -1 times minus 10x is 10x. Okay, so we're going to leave that, and we're going to just focus on the x squared minus 10x. So the way we complete the square is you do a bracket, and you have x, and then you halve what the coefficient of the x is, so that'd be minus 5, and then square it. Now if you expand that, you get x squared, brilliant, minus 10x, fantastic, plus 25, right, we need to get rid of that 25. And so I'm going to now expand the bracket with the minus on. So we've got minus x minus 5 squared plus 25 plus 7. And then we're just going to add the 25 and the 7, and you should get 32. Now, if I'm to draw the graph of y equals minus x squared, it's just a graph that looks like this. But more importantly, that their maximum point on this graph is at 0, 0. And if we remember our graphic transformations say that if we have a minus 5 on the inside of our function, and so comparing this function, say this is f of x, part of this equation here involves a minus 5 inside the function. That minus 5 moves the graph to the right 5. Okay, so we're going to move it to the right 5. Similarly, if you have a function and you've got a plus 32 on the outside of it, which we have here, it's going to move it up 32. So instead of our maximum point being at 0, 0, it's moving to the right 5, so the x coordinate would be 5, and up 32, so the y coordinate would be 32.
You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.